So today we're going to talk about automated testing in the LLM world, which is a big, huge challenge that a lot of teams face. And we're going to get started with a little story. All of us together, we're going to build a new, amazing startup called LAMP.ai. It's going to be the world's newest and best LAMP-centric conversational agent. And you're going to be able to ask it questions like, how do I make a lamp? Users will be able to ask things like that. And of course, through the magic of AI, it will be able to answer a pretty good answer. How do you make a lava lamp? Great, that's a pretty good answer. And of course, our development team will try a few other inputs to make sure that it does really well as a conversational interface. For example, maybe how do I make a salt lamp? Does it okay on that? How do I turn a lamp on? Because users might ask lamp operation-related questions. And so it's great, and we give an amazing demo, and we're able to put it together really fast. And this is an experience a lot of teams have when they're building with AI, is you can get a demo together so fast, and it's really impressive. So we raised millions of dollars from venture capitalists. We're going to be the next unicorn. It's going to be great. And then we launch to users, and then users do things, unfortunately, that we don't expect, we hadn't imagined. The user asks, where do I get the lava? And Noah thinks it's in Minecraft and is talking about lava buckets, and it's a bad answer from the AI. And this is a really common experience we have when we're working on these LLM-powered products. User asks something we didn't expect, or in a way we didn't expect, we get a bad answer, and then we find out about that somehow. Maybe they give us a thumbs down, or we just, someone yells at us, or whatever. And so we do some prompt engineering, and we inform it that it's not actually lava, it's wax. And so we get a better answer down there, but actually up there we now have a worse answer. Now the thing that was working well before, it's talking about wax. So we do some more prompt engineering, and then we fix that answer, and then there are no more problems until more users come along and ask more questions. Can I drink the contents of a lava lamp? And the LLM says humans are capable of drinking any liquid. And that's bad. Oh no, let's fix that. So prompt engineering for that. And then a user here is able to convince the LLM to express its love for them, which is really what we want. So we add a bunch more into the prompt to convince it to be aware that it's a LAMP-centric AI. And that fixes that, but now that's all it's talking about is being a LAMP-centric AI. And we're just playing whack-a-mole. And whack-a-mole is a term I've heard from many teams that have been working on LLM-powered systems when they don't have rigorous and thorough automated tests. It becomes hard to change things and hard to iterate. And so the solution that a lot of teams come up with is a technology called Steve. And this is a senior product manager, maybe a product engineer, maybe a clever QA person. And what Steve does is he receives requests. Hey, we're going to change the model from this to that, so could you just copy and paste all those prompts that that users sometimes ask into the system and tell us if things are broken or not, or if they're better, or do a vibe check? Unfortunately, Steve does not scale. You don't get super far with this. This is fine for your first few users, for a pilot project, but we need something that actually scales if we're going to be the unicorn that we can be. And so that's the problem we're going to try to solve today. We're going to solve the problem of Steve. First, who am I? I'm Pike. Quick background on me. I computing science, was a software engineer at Apple for a while. I founded a company called Steam Clock here in Vancouver. It's a product studio that builds products for other startups that I ran and grew for many years. But over the last year, I have handed that off to the wonderful team there, and they're continuing to grow and build Steam Clock. But in order to found an AI product company, surprisingly, you would find an AI product company founder here at an AI Meetup, which is called Forestwalk. And as the work that I've been doing in Forestwalk, I've had the fortunate circumstance of being able to interview more than 100 people about AI engineering and about evals and testing. So I've learned a lot about that over the last 6-8 months that I've been doing those interviews. And I wanted to share with all of you some of the things that I've learned about evals, testing, and approaches that teams are taking, what I've imagine hearing. And take that from a lens of a software engineer or an AI engineer, because there's lots of information out there about how maybe might evaluate if you're a machine learning engineer and you're training your own foundation model. That's great. Good for you. I'm glad you're off doing that so that we can go apply it. But I come from the perspective of someone being a product-centric engineer, and so that's kind of the lens that I take on this and how I'm going to share what I learned. So what should our tests be, if not just a product manager that we're always harassing to test stuff? Number one, our tests should prevent regressions, which is sort of the beginning. That was the beginning of our pain in the LAMP AI scenario, and it's the beginning of most teams' pain. That's where they initially start thinking about evals from, is, oh, hey, things are breaking, we need them to not break. So that's often the origin. But the bigger lift, and you could hear this a little bit in Peter's talk before me, is that when you have evals, that actually facilitates a more important thing as your product evolves, which is accelerating the exploration of the product. So allowing you to try different models, different prompting approaches, different techniques, different ways that you're chunking up the context. So if your testing is a huge facilitator of that, which is true with traditional unit tests, but in LLM-powered applications, like an LLM is a black box or a sort of transparent, weird black cube with a weird dragon in it. It's something that we don't really know what's inside, and so you need to be able to explore and experiment in order to understand what it's capable of. Your test should also support optimizing latency and cost. So this is one of the huge things that obviously cost has been from the beginning, and Peter again was talking a little bit about this. It can be a huge stumbling block for certain teams trying to do certain things. But increasingly over the last 12 months, the teams that I've been talking to have actually been focusing more and more on latency. Because if users are not getting a fast response from your system, they're not going to use your system. And people are seeing this in the user data. So even if you have a really powerful model, oh, I have 1 million lines of context, I can fill all the context, and even if it doesn't get confused by it, it takes forever to respond, that doesn't tend to get used. So teams are often using evals as a way of figuring out, and tests as a way of figuring out how can we use a smaller, cheaper amount of context or model in order to get those latency numbers down. Your test should represent real user experiences. This is a huge challenge a lot of teams have. It's easy to write a test, but there's such an incredible variety of actual types of user input. So that's one of the core requirements. And lastly, your tests need to be easy to add to and iterate. This is a wall a lot of teams hit at a certain point when, if it's just one person that's maintaining a ridiculous Python notebook or something like that, that tends to also not scale. So these are some of the requirements that we want to have in an LLM testing system. So we're going to start writing some automated tests, and we're going to start with phase 0. We're going to test on users. That's where most people start, which is fine. Almost all software companies, we test on our users. Maybe those are internal dog fooding users. Maybe this is we put things out and we collect the thumbs up and thumbs down. That's like a worthwhile thing to do. Pretty much everyone does that. But effectively, when we're doing this, we're sort of writing like a very, very slow test, which is like we ship something and then like the thumbs down rate, did it go down, or is it the same, or oh, did it go up? Oh no, revert. And this is a really slow way to test and experiment. And as your product gets more and more complicated, especially because we're building on these LLMs, which are these stochastic, complicated black boxes that have non-deterministic behavior, a small change can have a big result. You can A/B test big changes to any piece of software, but you would never A/B test a typo fix. But I've heard from teams that fixed a typo and that actually caused a regression in their prompts, because it's like, oh, I don't know, the prompt took that typo to mean a certain amount of casualness or something like that. And so you can't A/B test every single change, and so you need some way to reason about before you deploy that change whether or not it's better or if it is worse. So teams pretty quickly will go from these user tests to actually writing some objective tests against their systems. This is something, obviously, we have, as an industry, adopted unit testing as a great methodology of ensuring software quality. And so a lot of the same principles that we get from unit testing, we bring into our objective tests on our LLM-powered systems. And so we might write a test like, okay, well, is the output from this prompt going to give less than 200 character response? We want it to be short and sweet. That's really easy to write a test that verifies that. Of course, when we are looking at an LLM-powered system, we aren't just curious about 4 input cases, like when you might be some unit tests have just a few cases it tests. We might be interested in hundreds, thousands, or I've heard of teams having tens of thousands of data points that they run through their tests. And especially because the systems are non-deterministic, often you'll end up with a test that's more like this. The output is less than 200 characters 95% of the time. But these are still great, and there's a whole horde of things that you can evaluate. It's just like a simple, is it valid JSON? Is it matches regex? Does it have this text in it, or does it not have this text in it? So there's a bunch of like fairly mechanical things that you can do to test your outputs, even though it's a non-deterministic system, if you have a lot of example inputs. But this also hits a wall, because there's a lot of things that we use LLMs for, actually not honestly, pretty much all the things we use LLMs for. We care about using an LLM for it because it can give us subjective, nuanced outputs that might vary a lot. We're not doing simple procedural stuff that's always the same. That's why we're using an LLM. And so what teams get to after they sort of cover their basics with objective tests is going from the objective to LLM grading, which is what we tend to call evals. This is Simon Wilson. He's one of my favorite writers and speakers on this. He actually also created Django, but he's been really into LLMs recently, and so if you're not following him, you should be. And he summarizes here something that I've heard from a lot of the interviewees, and something I've observed in a lot of the interviews that I've done, which is the people who are doing the most sophisticated development on top of LLMs are all about evals. And they've got really sophisticated ways of evaluating the prompts. And what he's talking about here is not just like a whole bunch of tests that check if it's valid JSON, but actually like LLM-powered loops for a very wide breadth of features and sub-features. It's not just like each prompt has one test, but a whole bunch of tests that test certain aspects and evaluate certain aspects of a prompt, but also for a lot of data. And so the next phase that we get into as we leave the world of simple objective tests, typically in almost every team that ends up here, is similarity evals. So the next level of sophistication is checking to see, okay, we have a system that can take an input and it can generate an output, and we collect or curate or generate some set of ideal known outputs that we think are a good output for all these various inputs on the system. And then we have a bunch of tests that are basically this. The output is substantially the same as some ideal output. This is sometimes also referred to as the golden output, or a golden example. There's a bunch of different terms people use for this. Almost every team that I've talked to that has hit a certain level of skill with of LLMs has built some system that does some version of this similarity check. It's probably the most common type of testing that I've seen. Even actually honestly more common than the mechanical ones. And that's because it provides you like a safety blanket. You're like, hey, these things didn't really change. I have this score, I did something, I have some sense that the outputs of the system after this prompt change didn't change in a big, meaningful way. Of course, there's a little bit here that says output is substantially the same, which is, might seem actually like a non-trivial assertion to make. What does that mean for it to be substantially the same when the output, like in Peter's case, could be a whole bunch of prose with code examples and things like that? A common way, Peter.
Can I make a quick comment about this
Please.
one? So there's two approaches to this. One is to do like a vector similarity,
Yes.
where you create embeddings, and the other is to use an LLM to evaluate similarity.
Yes.
I'm sorry. Now you're talking.
Peter and I are like in sabbatical. So if you didn't hear on the mic, the two common ways of calculating this non-trivial thing is to use vector embedding. So you embed the output and you embed the ideal output. And so you basically create two number or vectors. And you say, how far apart are they? And then you have some threshold. If they diverge more than a certain amount, then we'll say, oh, they're not substantially the same anymore. That's a really relatively cheap way of running this test. But one thing I've started to see is more in my interviews is more teams actually using LLM-graded similarity check. That's partially because the cheaper LLMs, we're getting more and more powerful cheap LLMs. And also, as companies scale, the ratio of how expensive it is to run your tests versus how expensive it is to run in production goes down and down and down as you have more and more users. And so I've been seeing teams use cheap models and relatively fast models to prompt and ask, are these two outputs substantially the same? Which lets you then give it more direction, not just are these two embeddings vector similar, which might necessarily pick up something like tone or something that's not really picked up in the embedding that you're using. And instead you can say, ask an LLM, GPT-4o Mini, are these things substantially the same? And by substantially the same, I mean, do they have the same content more or less and the same tone in terms of X, Y, and Z? So that's a technique I've seen teams using for this. However, this also then hits a wall. Because you can create huge numbers of tests for huge numbers of examples where people are making sure, oh yes, this is still more or less the same as that, and this is still more or less the same as that. But often these tests, not universally, but often they degrade into just change detectors. Like if you work on a system that has a bunch of UI tests, that the test is just asking like, is a button called log out still literally here? And then someone renames it to the sign out button, and then the test is like, red, this system's broken. And it's like, no, it's still good, it's actually better now, but the test is unhappy with you. And so a lot of teams end up, if they are only focusing on the similarity evals, they end up with that problem. The other problem that often comes up when you're only focused on this is it's difficult to use this similarities type system to give your team like a benchmark to try to rise up to. Something that we see the folks on the model training side know this, that if you set like an aspirational benchmark that it's like, oh, we want to try to achieve this, and this is like some evaluation that currently we only hit 53% on, assuming that that eval is actually good and represents like what humans would think is 53% out of 100, then you can use that as sort of like a rallying thing for a team to kind of pull together in a common direction. But it's very difficult to do this with these kind of similarity evals because often, like I say, they capture, the ideal output is often a captured example of a real system output. And so that's not, you could probably achieve close to 100% on that. So like I say, they become change detectors. So in order to rise even above that, we get to phase 3, which is just LLM-powered evals. And so these can be anything that an LLM can consider. At the biggest frontier model, you could just ask, is this output succinct? Of course, if you've used LLMs in engineering, you will probably be able to tell, and as Peter was mentioning, the LLM that created some output that's not succinct might think it's succinct. And if you ask that same LLM, is it succinct? It might say yes, and that was why you got this non-succinct output in the first place. So this is a non-trivial problem. There's a bunch of ways of tackling this, though, and to get better results. And so one is just to be more specific. You can say, is this output empathetic? And by that we mean, here's a bunch of descriptions of what we mean as empathetic. If you want to get into it, you can actually have like a multi-shot example where here's a bunch of unempathetic examples, here's a bunch of empathetic examples. The sky's kind of the limit on terms of the prompt engineering, and even in some cases, teams will fine-tune models just to evaluate certain metrics. Obviously, that's a bunch of time investment, but it is getting easier to fine-tune models, and that is something that is starting to happen. Another really common thing that people use LLM-graded evals for is checking for hallucinations. So you can be basically effectively asking, I've gotten some RAG data, I pulled it into the prompt, I said, please answer based on this data. Did you do that? Is that actually what you did? And this is an example of something where it might seem like, well, if the LLM can't generate a good answer, why would it be able to detect a bad answer? And that's actually a property, 18 months ago, a lot of people were skeptical about this kind of eval, but it's becoming more accepted. The better models are better at it. And also, we're getting more used to the idea that LLMs, like humans, are better at identifying a problem than fixing the problem often. So it can be like, there's something there, hey, make a good output. Here's a good output. Was it good? No, I'm sorry, I failed, right? And that's actually, you want to?
I'm just going to make a comment on the correctly grounded thing.
Yes.
We had a lot of success with that once we started to heavily lean into chain of thought type techniques.
Yes.
So this is where you give very precise criteria for what it needs to analyze and identify, and then get it to spit out how it did its analysis, and then finally get it to spit out the summarization or the
yes.
eval.
Yeah, so and that's a general, so Peter was saying that you can use chain of thought and really in-depth, handhold this chain of thought, not just tell it use a chain of thought, but use this specific chain of thought when you're analyzing, is this empathetic, is this grounded in the RAG data, whatever you're asking. This is a general thing with evals, is when you're doing LLM-powered evals, you can afford, because you're running the LLM-powered evals a lot less than you're running your production system, you can use a bigger, heavier model, the bigger, heavier prompt, and the cost in terms of latency and price of that is a lot lower than doing that for all the user outputs. So it can be feasible to do that. Another example is maybe you have an AI that's telling people to drink a lot of lab fluid, and so you want to detect it that's doing that. That's something an LLM is going to be able to do that a lot more easily than a regex or something. So this is great. It's an incredibly powerful technique. You could spend person years developing these in a really large team, and it's really high ROI activity. But when you're building these LLM powered evals, there's a huge problem, which is that LLM might consider, yes, it's 100%. But if that doesn't actually agree with human experts about that topic, you've not done something useful. You've just created a number that's high. And so that's what brings us to phase 4, and as yet the pinnacle is meta evals. And so this is kind of the frontier of the eval work. The most sophisticated teams are doing this in a systematic way. The sort of middle sophistication teams and smaller teams are doing this in an ad hoc way. But what this is effectively tests that test your tests for their agreement with human experts. I heard you like tests, so I'm going to test your test. And this is something that is incredibly important when you're developing new evals. So sometimes people just do this manually. It's really common. You'll have people passing around Google Sheets like, hey, there's a lawyer that's going to be testing this contract writing thing, and so I want the lawyer to agree with the eval, so I'm going to have an eval, I'll put a bunch of stuff, and then send it to the lawyer, and then have them put their considerations, or how would you rank this NDA, or whatever, and then use that as part of your iteration. But the larger teams and the more sophisticated products that are building more and more evals as the product gets bigger and the user base gets bigger, end up building workflows and custom tooling to facilitate this process. So there's a great blog post that Peter actually turned me on to for the team at Elicit that talks about the workflows and the tooling that they build to manage and build out the meta evals so that then they can actually have confidence that their evals are actually agreeing with humans, and then that lets them iterate their evals. Because one of the big problems with evals, I think this came up in the last talk a little bit, is that you can prompt engineer a really good eval, but then you might want to change something about it, or you might want to change the model. A new model comes out, a cheaper model comes out. And so if you don't have some way to scale out retesting that eval to make sure it still agrees with an expert, or maybe the expert opinion changes because we've learned more about our product. And so this is a necessary thing at a certain scale. Something that I've sort of glossed over so far through all of this is I'm sort of talking as if I'm assuming you have a whole bunch of data you can feed into these evals. And a question that often arises when teams are looking at getting serious and scaling up their evals is where do I get the forking data from? This is a huge problem in the eval space. There isn't a simple answer, but there are answers and there are approaches. The sort of bad answer is you handcraft some data. How hard can it be? We'll just we know what our users type in. We'll just type in those same things and we'll create some data. And that's often how teams get started. But obviously this doesn't scale. If your development team knew exactly what users were going to input, then you wouldn't have a lot of these problems. It's the fact that users do things we didn't expect. And trying to handcraft large volumes of data, people, even if you could afford the developer or PM time to do this, people just get exhausted and they stop creating good data. And it's not going to be very diverse. The next less bad way to do it is building synthetic data, and almost every team that I've talked to that has skill evals is doing this to some degree. They're generating synthetic data that represents use cases that they want to test more rigorously. Obviously, this also can have a problem. If you talk to people 18 months ago about synthetic data, a lot of people would be mad at you because the LLM cannot create data that gets then used to create the LLM. It's like a snake eating its own tail. The kind of famous, or I think of as a famous example of a problem with synthetic data is that if you ask, it's the Willow Creek problem. You've heard of this. If you ask GPT-4 to write a small town romance, it will always be set in Willow Creek because GPT-4 thinks that's the most statistically likely place for a small town romance to be set. In production, your users are not going to think that way. They are going to put every possible thing in. They're going to put things that are wrong. They're going to put in things that are weird. And they're going to put in a wide variety of actual inputs. So one way that teams deal with this is they'll start to build kind of like what I've heard called a world simulator, which is like a mix of an LLM and like a data generator that generates like a wide variety of actually statistically probable information. So like, I hook up a data source for like addresses in the USA and make sure that the zip codes actually match. Because if you just ask GPT-4, create a bunch of addresses, it may create addresses that don't exist, or the zip code doesn't match the city, Willow Creek isn't even the place, or whatever. And that can screw up your evals, because users are probably typing in mostly real addresses. So synthetic data has its challenges. It's not a panacea, but it's actually quite powerful. But it's not nearly as good as the #1 most amazing, wonderful, best way to get data, which is your real production data from actual users, from traces. We love it. This is the gold standard best way to build your evals. Obviously, if you don't have any users yet, then that's challenging. But most of the teams that are really doubling down and starting to invest in building evals are at the point where they have enough users that they're finding enough edge cases that they're needing to sort of scale up. And so often this is possible, at least in theory. Something that I've heard from so many interviewees, and I've also read this, I've heard this on podcasts, a really common idea, is that you should be looking at data. This is Hamal Hussein. He's another one of the folks I like reading about, especially on the topic of evals. He spends a lot of time thinking and writing about it, and he's an independent consultant, so he can write whatever he wants. He's not locked away in some AI lab. And he summarizes this in a way that I think is true.
He's going to lab now.
Pardon? He has joined lab now, but he still writes as far as I know. You're doing it wrong if you're not looking at lots of data. And this is just something I've heard over and over again. The teams that sort of just use their product and then they just like, they maybe guess how users are inputting it. They guess, make synthetic data and just hope that it represents real user data. Those teams are struggling really relative to the teams that are spending a lot of time actually immersing themselves in the data. If you talk to a data scientist, they will tell you this, that you should be looking at the actual data and not just trusting. So I'm doing a lot of encouraging you all to look at real customer data. Some of you may have an objection. It's like something along like this. If you don't know what SOC 2 is, then God bless you, you're lucky. Those of us who work in a B2B world where we're providing software for other businesses often are required to comply with SOC 2, which is a set of security protocols around data governance, and making sure that you don't just like let everyone in your company look at all the customer data, which is exactly what we want to do in order to build really great systems that are based on that data. So there's a whole bunch of ways that teams kind of manage this and tackle this. One is just if you are not a B2B company that you just have in your terms of service, hey, we can locate your data in a secure way in order to ensure system health and provide testing and stuff like that. And most users of most systems, if it's like a D&D app, will be like, okay, cool. And some like small businesses won't mind that being in your terms of service. But if you get to the size where you're negotiating enterprise contracts, then like that's not going to fly as a default. Like, hey, by the way, we're going to look at your data. You need more. So one of the techniques teams use will be redaction. And so redact out all the PII, all the email addresses, all the addresses. We'll just generate those, right? So it's not Willow Creek. But redaction is helpful for this when you're in conversations with customers or you're figuring out what bounds you want to try to set for this. The other approach that I've heard a lot of teams talk about is they get explicit customer permission from a handful of customers where they've built a trust relationship with. So if you're onboarding, some huge company comes to you and then it's like, hey, Microsoft is going to use your thing, then they are not going to agree to you looking at any of their stuff in any way that they don't have to. But if you have a customer that you work with since the early days, you built a trust relationship, they understand that you're not just like by saying you're not gonna look at their data, you mean, but have specific boundaries and limits, and you're gonna do it for a way that will help them. For example, like I've heard of teams where if the customer says, hey, we have this problem, your AI tool is really useful, but we have this problem with the outputs in this case, they can say, hey, well, you can opt into our program where if we're able to, in a secure way, use some of your data in order to help our testing. And of course, a lot of people don't want you training on their data, so that's another terminology maybe avoid. But in order to be able to make sure that your changes work with their data, you need something that is like their data. So that's a conversation you can have. Finally, a technique I've heard, which I find kind of horrifying, but it's like actually kind of cool, is that I've heard of teams where they're really strictly not allowed, their engineers cannot lay eyes on the data in the real system. But they want to be able to update the prompts and the system in a way that's safe. And so they build a bunch of evals that run on the customer's platform, on their virtual servers, and in their VPN and all that kind of stuff. And so when they want to make an update, they will send the new prompts and the new system to the customer's thing, and they'll run a bunch of evals, and then it'll be like, the evals were bad, your prompts were bad, you should feel bad. And they don't know why, because they can't actually look at that.
Unless they talk the customer into running an LLM locally, that will then summarize it in
Yes.
an active way for them.
So this is the loop. Is like you basically say, hey customer, look at this thing. It says it's bad. Can you tell us why? And then the customer is choosing to share either in a redacted way or they get to choose the redacted. And often customers will be like, oh, it's exactly this, and they'll just paste it to you. But they want to be in control of the data sharing. So I'm not super enthusiastic with the idea of working on systems where I cannot in any way expect them running. But it's extremely profitable if you can do that well, because really big enterprises much prefer that. So that's an option as well. So I have just rapid speed run a whole bunch of problems and goals and things that people are doing around evals. But in order to actually do this, you need tools. And in the more than 100 interviews I've done, the majority of the teams in 2024 October that are doing a pretty sophisticated, or really even medium sophisticated amount of evals have built a bunch of their own tooling around it. And because this is more or less a universal need. If you're going to scale out an LLM-powered piece of software, you need tooling for this. And that's why a large number of startups have popped up over the last couple of years that are building tooling in this space. These are just a few of them. We have a spreadsheet of over 80 of them, ranging from the startup that is using Comic Sans as their logo, all the way through to this little startup called OpenAI. I'm not sure if you've heard of them. They've just launched a little eval tool that's pretty simple, but they're in on the game too. And also, that's we're doing some stuff related to Forestwalk. I'm not going to talk about that today. Not because it's a secret, but that's not what I'm here for. My point with all this is that there are a lot of people building tools for parts and aspects of this system that each have their own different, ideal use cases, angle on it, part that they're focusing on, tooling preferences, user experience and workflows, and there's a whole big, battle going on with people exploring and finding different ways of doing this. Happy to talk about that at drinks after. But before I go, I want to summarize the dream that's in sight. I've done all these interviews, talked to all these people, and seen sub-parts of an incredible LLM eval testing experience. where they have tests for every user experience. Not every prompt, but like every sub-aspect of the experience that as product engineers that they care about. They have extensive data that actually represents real customer use cases or representative customer use cases. They can easily collaborate on it across the team. So not just, it's easy to collaborate on the evals, but the existence of evals makes it easy to collaborate because you're not going to break someone else's stuff. They track the performance of those evals over time, so they actually have a sense on in what ways the product is improving and in what things are maybe getting worse because they're choosing to make trade-offs. The tools are well integrated in with all the other tools because they have observability and operations and their IDE, like the best teams have the ability to run that stuff locally, but what does that look like? And of course, because it's the best way to build software, it's the right way to build software, it's all beautiful and fast. I haven't talked to a team that has all of this yet, but I've talked to teams that have parts of it. Of those various tools that are being built, you can see glimmers of this future. So this is the future I want for all of us in our LLM eval world. So hopefully that like excites you, or at least it doesn't terrify you. So I encourage you all to go level up your evals, and if you'd like to talk more, then come say hi to me afterwards. Okay, Hendrix. Thanks everybody.